Let's see some options of the different projects that we have been working on recently. I try to build up a logic in how I'm going to walk you through the different project types, and then I will end up at the most complicated 4D, 5D, really detailed modeling projects, but I will start with the fast-track business development projects first. So as I mentioned, the business development projects, we use this term when we are involved in a bidding phase, and we have really just design development or schematic design documents, but we still have to put together building information model on one hand to show the owner the BIM capabilities that the company has, on the other hand to reduce risks and run a couple of what-if scenarios, different variations, for example, for facade or different phasing and different scheduling variations. As you can see on the right-hand side, this stadium was put together for this purpose, and a full 5D project, a full 5D was run on this stadium. So therefore we could give presentation materials and what-if scenarios to our client. The 3D model evaluation, Holly already mentioned this one as well, and we had a webinar in the topic, I think last December. So you may be at a point when you have different models, you have designers putting together 3D models for you, or your subs are working on 3D models, but how can you make sure that it fulfills your purposes and it really provides you what you need? So we came up with an idea, we came up with a service which we call 3D model evaluation, and if you want to be sure that the 3D model was put together as you imagined, and it will be good for, let's say, coordination or later on 4D, 5D purposes, you can hand over the models to us, and based on some criteria, which is usability, consistency, quality, and we can talk about 4D, 5D as well. So based on a criteria system, we analyze the model element by element, line item by line item, and give you a feedback what we found. As you can see, in the end, we will come back to you with a couple of different percentages, and in general we can say if your model reaches approximately 80%, then it's good to go, and you can later on use it for the purposes that you wish. But if it remains below 80%, we will recommend a couple of different changes, and then it's going to be your call whether you want to have these changes made by the owner of the original models, let it be the subcontractor or the designer, or you want us to help you out fixing the models. We can also give you a couple of images and reports to see what the issues may be in the model, so you have a better understanding of why we are suggesting to work on different portions of the model. In this case, for example, if you want to use a model for coordination purposes and above head coordination, it would be great to have all the ceilings in place before we start such a job. 3D constructability analysis. This has become throughout the years one of our basic deliverables, and we do it on all projects. We do so because as we build the models, I can assure you that we always run into issues, let it be missing pieces of information or collision or contradiction between documents and different trades, and we just don't want to keep these issues to ourselves. We rather create nice reports and give these to you. And you will be able to use that on site. We are probably still ahead of construction, so you will have time to make the necessary changes and decisions to avoid the actual issues in the real-life construction. It doesn't have to be MEP, so it's more than a collision detection only. It's an analysis made by our engineers, so it's much more than a software could do alone. I will show you another example for such such a constructability report later on when we go into a really detailed case study of a detailed modeling, which is the Mission Hospital. But you can see a couple of different reports on the screen right now. So you see that we not only report the floor plan location or the area where the problem occurs, but we also create section views and 3D views. So it's much easier to find these issues and analyze the issues, and again find them or work on a couple of what-if scenarios and solutions. Coordination resolution. Again, a topic which we had a webinar about a couple of months ago. So I will just recap what that webinar was about. Coordination and MEP coordination is an existing service. It was not found out by us, but what we found is that how the subs are doing the coordination is not the most efficient way. So again, being a process-oriented culture and organization, we are always trying to find the best way of doing different services and eliminating the not necessary steps from it. So nowadays, when subs are doing the coordination, they get together with their own models on weekly or bi-weekly meetings, and they run the clash detection and identify the issues. And let's say they find 400 issues one week, then they go back to their offices and start working on fixing those issues, moving some pipes and ducts around, and while not knowing what the others are doing, most likely causing new issues. Then, so when they get together in the next meeting, they may have to face 600 issues instead of the previous 400 issues. We think this is not the right approach. So what we rather do is to take all the different systems and following our own system priority structure, modeling the systems ourselves, and just basically not modeling the clashes. It's much better doing it first, doing it right for the first time, and not going back and fixing again and again. So avoiding the clash allows us to save approximately 40% time and 50% in cost compared to the traditional 3D coordination processes. As a byproduct, we also provide 2D installation drawings in the end of the project, so that can be used for installation by the subcontractors. A couple of examples of our recent coordination resolution projects. So this medical research facility is located in Boston. On 14 stories laboratory, you can imagine how complicated an MEP system of a laboratory is. And together with the architecture and structural background modeling, we managed to deliver the project in 14 weeks. Again, a research facility in Australia. It was including architecture and structural modeling as well on 9 stories. The services duration was approximately 12 weeks in this project. And the military training facility in Vermont. I cannot show you an image about this project because obviously it's a top secret project, but the 2-story training center facility was carried out in 10 weeks. I show you only one image of a coordinated MEP system because I'm pretty sure as coordination is an existing thing, you have seen a couple of images like this. But I rather show you a 2D document that we create in the end of the exercise. Currently, you can see a duct, let's say a return air duct system on the screen, but we not only create the drawings for each and every system separately, we also create a composite drawing that you can analyze in the project, in the site. So it is a really detailed drawing with all the necessary annotations, with bottom and top heights and horizontal locations as well. Involve coordination goes hand in hand with above head coordination, and again I can say the same as I said at the previous slides. We had a a webinar 2 weeks ago about this topic, so I'm just going to scratch the surface and really talk on high level about this info coordination service. So if you are facing a really complicated building, just like a medical office building, not an office building, but rather a surgery, you want to make sure that everything is going to fit in your building and you are not going to have clashes. Moreover, you are not going to have, you don't want to have too many change orders. Basically, you don't want to face any change orders after delivering the project. So you have to coordinate everything which is going to be routed or placed inside the partition walls. It can be the studs themselves, but it can be, for example, for the heavy casework, it can be backings and medical pipes and other piping systems in the wall, as well as electrical telecommunicational systems and different types of electrical panels and things like that. So you have to locate and route all these elements in the wall. On the surface of the wall, you have to, and let's stick to the example of a medical building, you have to place different, let's say, medical equipment, which can be on the bottom line. You can see, for example, X-ray screens and different medical screens. On the top, you can see a simple drinking fountain, but obviously it requires some drinking water as well, so a piping behind it. But you can find as simple objects and elements as a hand sanitizer. We have to locate all these on the walls because even a hand sanitizer have to be located correctly in order to make room for the more complicated and more complex, more important elements in the room. And this one can be applied for any kind of buildings, even on office buildings. So whatever is placed in front of the walls have to be coordinated. If we are talking about computers and printers, they have to be not only placed on the casework, but they have to be provided power supply and data supply. And during this exercise, we found that this is missing in very many cases. So we found the printer locations in the plans, but there was no power provided to the printer. So obviously that would not work. Or we found, for example, data outlets and power outlets hidden behind the casework. So it would have been a change order, obviously. This project, the St. Jude Medical Plaza in Fullerton, was a nice challenge from very many aspects, because the construction was already ongoing when we joined the project site. So we had to catch up with them. Moreover, we had to get ahead of them to be able to provide valuable input for the client. The client had a pretty nice goal, and the goal was to reduce the number of change orders after the building is delivered to the end users, reduce the number of change orders dramatically, which means to reach the zero number of change orders in the end. So we built up a process for it. We decided, being a 3D modeling company partially, we decided to build up a 3D model for this exercise and just coordinate everything that we have to. And we managed to get ahead construction. We managed to reach the zero number of change orders, so the project was obviously a success. We managed to reach the zero change orders because in the end of the exercise, we involved the end users. We had sessions when the nurses and doctors could review not only the 2D layouts, wall layouts that we created, but also the 3D models, so that they could better find out how their final work environment will look like. And they did request changes. So for example, we found that it makes a difference if the doctor is left-handed or right-handed, because he or she has to stand on the opposite side of the patient. So obviously the entire room has to be set according to this requirement. Another successful project was the Mission Hospital in Mission Viejo in California. It was a really detailed virtual mock-up, which means that we not only modeled the standard elements, which would be probably the beams and columns and slabs, but we also took the shop drawings of the panel system. You can see on these renders that the project the building was covered with metal panels. So we took the metal panel shop drawings and we just built all these different pieces of metal panels individually and then put them on the building. We ran into some issues, I have to say. But you can see on the screen right now, besides the awards that the project won, you can see the east elevation of the project, which caused the most issues. This is the final, or almost the final picture of the elevation. You can see that it's almost completed, and it was successfully completed, but it didn't look like this all the times. During the project execution, we found that the steel structure wants to stick out from the building, and it wants to penetrate the metal panel system, which is obviously not good. So during our deep analysis and constructability reporting, we found these issues reported on site, and luckily we were in time enough that we could, or the project team could put the metal panel fabrication on hold, and they could redesign the certain parts to order the matching metal panels. So as I mentioned, we worked on the east elevation and we found the most issues on the east elevation, but we also worked on other locations of this building, and in total we found that the panels that we were investigating were 40% false, so 40% had to be redesigned before installation. Just a couple of numbers to run you through. I think the most important number is in the end, which means that with this service we managed to save $1.8 million to the client because it didn't cause 10 weeks delays in the project, and they didn't have to send back the useless metal panels to refabricate them. 4D, 5D, 6D projects. Basically, whatever we do, let it be a 3D constructability analysis, is ready for 4D, 5D. It means that we have our structured modeling systems. We use our content planning systems and processes. We use our virtual warehouses. And we have our own Vico Office cost database. So it means that at any given point in time, our model is ready for quantity takeoff and for scheduling. 6D facility management is another service that we can add to the package. So if you have a detailed MEP model, let's say, and you want to add deep and more information to the above head systems and equipment, you can do so in our models. This is about our standard projects. These are the projects that our experts, teams are working on in very many cases, but we have some special projects as well. And these projects are more related to our project engineers and on-site project managers who are working on site with the project teams. So for example, on these images you can see how we walk through the construction with the owner and with the GC, and just collect the productivity data and enter them into the previously created project plan in Schedule Planner and see the results. As I mentioned it back half an hour ago, we put together our own schedules as well, our own project schedules as well in the Schedule Planner, but obviously it was designed for construction. And as we are walking through the construction and collecting this productivity data, we will be able to then forecast what's going to happen in field if we are following these actual productivity data or productivity rates. If needed, we can alert the project team that they have to make changes because they are going to get in trouble soon. the same topic, you can see how the location-based data is being collected right now. And on the same meeting, you can also see how our special 2D documents and annotated MEP drawings are being used by the subs for both installation and measuring productivity. Our project engineers are that much involved in the construction that they have, as I mentioned in the trailer, their own desks, and they like putting together their own walls, production walls, and having the A3s on the walls. So these sheets are showing the different locations of the project and also showing the actual productivity data that they collected.